Whoop, there we go. I think my mic's on. Mic check, mic check. Good morning, everyone. Welcome to Wolf Web 3. My name is Cade. We're hosting these spaces with Hedera. Good to see everyone up here. I see Brett up here. I see Charles up here. I see Patchy. I see Greg. Good to see everyone here. Thank you so much for spending this Wednesday with us. Didn't know if there's going to be anyone speaking behind the Hedera account, but either way, can't wait to get in this conversation, guys. If you haven't already, please retweet the space for us. Twitter Spaces is not the best at letting people know that we are indeed live on Spaces, so please retweet the space. The best way to get the conversation out there. We're really going to be diving into the crypto trilemma, what really makes a successful chain, and something that is usable across industries, across big companies and corporations. What is it that sets Hedera apart? What is something that they offer that is really, really unique? And so I can't wait to get into it. We did a bunch of research leading up to it, and I can't wait to pick the brains of some of these people on stage here. I see Charles up in here. I'm not sure if Charles is going to be jumping into the conversation, but I see a bunch of familiar faces in the audience here. I see Brett up here. Brett, how are you doing, man?
GM fam, not too bad. Doing pretty good. It's starting to get hot here now, so I'm just trying to keep all movements to a minimum. I'll be at my desk for most of the day today.
Hey, I'll be right there with you in October, man. We'll both be kicking it in Colorado. So yeah, man, super excited to see it. So Greg, how are you doing?
I'm very good. Thank you for inviting us. And I'm in Europe, so weather here is warming up, but not yet to the point where you don't want to go out and move about. So all good.
Awesome. I see Patches up here. Didn't know if you wanted to just call me Patches or if you had a specific name you wanted to go by. Can anyone else hear? I can't. It's possible I'm getting wrong.
Nope.
Yeah, no,
I can't.
I can't
I can't
hear
hear him
him
either.
either. But
It's consensus. We've reached it.
yeah,
No, I'm just
Uh,
joking. That was
you know
that was
what?
a stupid
Call
blockchain
it,
joke.
everyone. Call it.
but maybe I can answer for you. When you joined the team, he specifically asked me to call him Patches.
You said call him Duchess?
Patches.
No,
Oh,
Patches.
Patches.
Patches,
Okay,
Cade.
got it. Got it.
Patches.
Good
Perfect.
night.
Charles, how are you doing, man?
Oh, dude, I'm so blessed. I've literally been building these AI LLMs just to train me on blockchain. I've been spending just countless hours studying gossip and the differences between, like Hedera and what other blockchains do, and really just blockchains in total. And to be honest, the more that you get into the tech, dude, it's just awesome, bro. Like it just gets cooler and cooler as you dive in. Like I was talking to somebody the other day about like Bitcoin. We went to the conference, and I won't belabor this, and I'm sure you guys, Patches, hey, Greg, hey, nice to meet you guys. Brett, of course. I'm sure you guys have experienced this too, but people will build bull cases around blockchain but not understand the underlying tech. And so I never realized this for the longest time. People build bull cases on price speculation, not even on necessarily understanding how immutable the thing is that we're working with. And the deeper I go into these chains, like Hedera or Bitcoin or whatever it may be, and they all have specific use cases that are unique and answer a lot of issues. Some of them are just extra redundancies, and they'll remain nameless. But a lot of times, what's really cool is that as you dig into the tech, it becomes even more bullish minute by minute when you really start to understand what's going on, why transactions can't be messed with, why it's immutable, why nation states can't break in, what makes this thing a big behemoth of decentralized abilities. So yeah. Anyway, that was long winded, but yeah. Hey, everybody, nice to meet you guys.
Hey,
Can you guys hear me now,
Hey,
or
Patches, loud and
we
clear.
can.
the old off and on? Yeah, nice to be here.
Perfect. Awesome. Yeah, super excited to get into it. Charles is right. He creates these really awesome custom chat GBTs. I don't even know what the word is, but I don't want to tell too much about it. It's like the best thing ever, and I've really been nerding out with it. And he's right. The deeper you go down that rabbit hole, the more interesting it becomes. The more questions you're able to formulate because you understand a little bit more. And I cannot wait to do the deep dive on Bitcoin. He's got one for those as well. But I mean, I never thought I would be nerding out about developer stuff and coding and things like this a little bit, and more things that are on the technical end. That's Bread's world for sure. I find it super interesting. I feel like when I was in that ChatGPT, I was learning a bunch, and so I'm really really excited to sort of expand on this idea of the crypto trilemma, which is which creates this. Actually, you know what? I'll let you guys introduce the crypto trilemma. I feel like you guys will do a better job than myself, and then we can kind of dive into why Hedera has got so many things to offer from a unique standpoint and why. So again, real quick, Hedera, didn't know if anyone was going to come in on your accounts, but I guess I can pose that question to Patches as well.
Yeah. Looks like we lost Greg. Twitter's firing on all cylinders right
He's
now.
back. He's back.
Is he? Yeah. Yeah. So. Hello.
Oh no. Oh no. We're getting rugged again. This can't be happening.
No, I can hear him.
Charles, are you messing with me?
You're on mute, Patches.
Yeah, he's just muted right now, but we could hear him for a second.
Oh, okay. It looks like he's off. It doesn't look like he's on the stage anymore.
Nice. Yeah, I had to quit and come back. I missed a question, so maybe I can pick up if you mind
Yeah,
repeating the
absolutely.
question.
Yeah, I was just saying, I was super excited to expand on the idea of the crypto trilemma, what we're talking about today. And I was gonna dive into it, but then I figured, hey, we got you guys up here. Would love to hear kind of how you guys define it, and then we can expand and go deeper on this for sure.
Sure thing. So, I mean, security, decentralization, and throughput or performance are typically the three tips of the triangle, and that's generally how we go about it. Now, I think maybe what is most interesting in this triangle is the governance or the decentralization, and how that is defined, because um, it's not clear cut, black and white, in my opinion. It's very much different shades of grey, depending on where you define decentralization to be required or to occur. Clearly, lots of people have different opinions on this one, and that's probably the one that's in my opinion, generating the most amount of confusion or disagreements. But yeah, generally that's how we look at it here at Hedera.
Awesome. Yeah, and sort of what I was reading up and finding was that most of the time blockchains have two of the three of the trilemma. So like you were saying, scalability, security, decentralization. Bitcoin itself has got everything but the scalability. And I've heard all sorts of conversations around that, especially with Bitcoin. They're like, hey, it wasn't built for certain things. Like that wasn't the goal. So that's why only two of the three are a focus point. Both Hedera, they've got some pretty um interesting points here, and some things that may help contextualize the rest of the conversation listening for people who are listening. Hedera is what's considered more of a hash graph, not specifically a blockchain, a traditional blockchain. Some people may not be aware of that distinction. So pretty curious on how you guys would give that distinction, and would love for you guys to expand on that a little bit on how your consensus algorithm with this hash graph differs a little bit from traditional blockchain consensus mechanisms.
Yeah, sure. I mean, I don't know how technical your audience is and how deep you want to go, so pull me back if I go too far. But I think one of the major misconceptions in the technology that we all love is the blockchain is the end all and be all. Blockchain and hash graph, well, or rather, blockchain and more specifically DAGs are often compared, and it's considered that if you're a DAG, you're fast, and if you're a blockchain, you're not. The reality is these two things are ways of storing data. That's all there is to it. You store data in blocks and they follow each other, and there's a hash that links them one to the other to make it harder to modify an old block. And what makes it hard to modify an old block is not because it's in a blockchain. I could build my file system on my computer as a blockchain, and I could recalculate all the hashes if I make a modification to an old block. What makes it hard to modify the blockchain is the consensus, is the fact that all the nodes have to agree to that modification, and convincing all the nodes in whether it's Bitcoin, Ethereum, or any other blockchain to perform a change to a block that's 2 months old or 2 weeks old is virtually impossible, although it is technically always possible. networks try and make this financially impossible, and that's what really protects networks with cryptocurrencies. Directed acyclic graphs, which Hashgraph is based on, is a different way of storing data, and in fact, blockchain is a type of directed acyclic graph with fewer possibilities for connecting different things to each other. So at the end of the day, when we compare a DAG to a blockchain, what we're really comparing is ways of storing data, not ways of reaching consensus or ways of propagating transactions throughout the network of nodes. So I generally struggle with just defining blockchain as a group because it's one piece of the technical components. So we know, for example, Solana is a blockchain, Ethereum's a blockchain, but they both achieve very, very different throughputs, yet they are both blockchains. So there must be something different, and it's the way they reach consensus, which is different, or their degree of decentralization. So Hedera is based on an algorithm, a consensus called Hashgraph, which leverages a DAG, to store not the transaction history, which is what is in a blockchain, but the history of communication between nodes for the purpose of reaching consensus. So in a typical network today, or a traditional blockchain network, one of the nodes in the network will be elected either through a calculation based on stake, and there's different networks use different means of electing their nodes for block production, or on Bitcoin through proof of work, proving that I solved a particular problem, and that grants me the right to create the next block. That block then needs to be propagated to the rest of the network. It needs to be verified and validated by all the network participants, and if it is so, it is enshrined into the history of transactions. With Hashgraph, the Hashgraph uses two kind of different. There are two key principles. The first is what we call gossip about gossip. Now, every network uses gossip to propagate blocks to the rest of the network. And gossip is like social media. You tell a friend something, they tell two friends something, those two friends tell two friends something, and before you know it, the entire world is aware of what you told your friend. That's gossip. And all networks use gossip. What Hedera, or what Hashgraph does with the transactions that it receives is the nodes will exchange the information about different transactions with each other, but it also, with that, in that exchange the provenance of that transaction. So an example I gave for social media, you tell your friend something and your friend tells someone else. When your friend tells that someone else, they also tell them that they heard this information from you. And that leads us to a capability within Hashgraph, which is virtual voting. Voting on the validity of transactions is all about ensuring that 2/3 or more of the stake of the network has seen or verified a particular operation or transaction. So in this case, your friend knows you know of this information, could be a transaction. It also knows because you've told him or her that I gave you this information, and there's a signature to go along with it, and everything to make sure you can't lie to your friend. So your friend knows the entire network, if we all have equal stake, is aware of that transaction. You do as well, because you've told your friend, and I told you, yourself, so 100% of the network is aware. And I happen to know that 2/3 of the network is aware because you and I know, but I don't know your friend knows yet. So based on those rules, we're all able to come to consensus on this transaction, even though I've never spoken to your friend. I don't even know who your friend is, potentially. And I don't know, and I don't know that he knows. So by combining this gossip about gossip, which is provenance of transactions, when it comes to who in the network of nodes is aware of this transaction, and this giving nodes the ability to virtually vote, in other words, they can vote completely independently of each other, and they always end up reaching the same result, we're able to achieve very efficient, very fast consensus compared to many other networks, without sacrificing security or decentralization. Does that make sense?
That did make sense. There was a bunch there. Maybe it made more sense because I did a bunch of research on this, so I heard a lot of things like the gossip protocol that I was super excited about. That I thought was really interesting versus like the traditional proof of stake. So that was all really cool. I think there's a bunch of different areas we could go down that one. I see Charlie's hand though, so I'll go to him.
Yeah, thank you so much for the breakdown. One thing I guess my question is, in comparison to traditional blockchains, where do you see like a gossip by gossip system with virtual voting? You don't have block, in a traditional way. Where do you see that excelling for use cases for you guys? Like, obviously, there's some stuff that, like Bitcoin and things like that, Ethereum with slow TPS, or like, slow transactions. Like you put the transaction, but before it like settles into the ledger, meaning the money is like confirmed where it's supposed to be, it just takes time. It takes a little while. So where do you guys see, this system that you've built really excelling use case wise, where industries, governments, whatever it may be, can kind of look at you and be like, you solve this issue, which makes this industry, excel?
So, I mean, of course, there's a few, and I would say, first of all, the latency on transaction confirmation is critical to many use cases. You may remember in the very early days of Bitcoin, the joke was that if you went and bought a coffee with Bitcoin, it would be cold before the merchant was guaranteed to receive payment. So, in some situations, it's perfectly okay to wait 10 minutes. In others, you need, confirmation within seconds. That is, one scenario. It's not just about throughput in terms of transactions per second. It's also time to finality. So how long does it take before I consider my transaction final? On Bitcoin, it could be an hour if you wait for 6 blocks. On Ethereum, it could be a minute if you wait again for 6 blocks. On Hedera, it's 3 to 5 seconds, and that transaction is final. One of the characteristic of Hashgraph is that we talk about 100% finality. So what that means is that when a transaction has reached consensus, it cannot ever be reverted. Whereas on most other networks, there is a notion of a transaction getting closer and closer to mathematical 100% finality. The deeper it is buried in the chain of blocks, the reality, and like I said, this is protected through financial mechanisms. If somebody was financially well off enough to own a majority of mining capabilities on Bitcoin or stake on Ethereum, they may be able to revert the history and actually go back a number of blocks and change reality. And this introduces capabilities for transactions being revoked, meaning that things that have happened in the real world are no longer valid, but they've happened in the real world. And we're talking a lot about real world asset tokenization today, fractionalizing real estate or other things. If I'm buying a piece of a flat, or if I'm buying a property, when I have the key to that property, it is mine in the real world, not just in the virtual world. If in the virtual world where I've paid for it, or where that ownership is revoked, then how does that correlate to the real world? So we see a lot of use cases that require low time to finality in number of seconds. Also high throughput. One of our highest use cases is Atma.io, when they're pushing in excess of 1,500 transactions per second. That's what their business requires. So they couldn't do this on Bitcoin or Ethereum. And then finally, because of the efficiency of the network, we're able to provide very low transaction fees. And again, if you're a business, low transaction fees are very important. I think we maybe forget that in DeFi, if you're trading hundreds and thousands, $100 transaction fee is okay. It's a drop in the ocean. But if you're selling goods and services to customers, paying $50 or $10 for a transaction on something that costs about the same is not realistic. So With those properties of the network, we're targeting high volume use cases, we're targeting high throughput use cases, but also very, very broad adoption. We're looking for democratizing the use of public ledgers. And if you just look at credit card providers today, they process far in excess of all of the ledgers combined in terms of transactions per second. So if we're hoping to replace or assist some of those services with crypto equivalents, we simply can't do it with 10 or 100 transactions a second.
Charles, by the way, I
Yeah.
tried to do a quick DM, but yeah, go ahead.
No, I was just going to say it's. I think what's interesting too in comparison to Bitcoin, a lot of these things, and I'll pass it right over to you too, Brad. But is Visa and MasterCard, we're so used to high transaction throughput. Greg, your mic is hot mic just a little bit too, just as an FYI. We're used to high transaction throughput where they're going very, very quick. So a lot of the industry has been built on fast transactions. Well, it's like, okay, so if most of the industry has come to a standard of understanding that things are going to be quick, it's very tough to sell blockchain to them because now it's like a loss and they have to figure out how to do workarounds, which is what they're doing with layer twos and all that stuff. That's why, Bitcoin's tough.
Mm-hmm.
Like ultimately you do get like 642 exahash of decentralized power, and so you have safety from nation states and all those issues. But when you're talking about actually producing what you guys are talking about, which is like throughput and industry on top of it, people are used to quick transactions now. Like trying to go backwards for adoption is extremely tough to do, especially when you're selling it to large industries. So yeah, it was just an amazing take, Brad, and then we'll go Patches.
Yeah, this is a great conversation. A couple questions about Hedera, right? Because I'm a blockchain developer, right? And being that hash graph is. Can you hear me, Greg? Maybe. I mean,
Greg, can you hear Brad? Greg?
I can't, no.
Okay. Do you mind? I can hear Brad. Let me. Charles, are you able to hear Brad as well?
I can. Yes, sir.
You can. Okay, Greg, do you mind popping off real quick? I'll bring you right back up on stage, but you may close out the Twitter app. It usually gets rid of most of the bugs.
Yeah, well, he takes a lap. I mean, yeah, Hedera is awesome. Especially when it comes to, again, solving that trilemma. Because as far as security goes and throughput or speed is yeah, they crush it. You know, it's kind of like the decentralization aspect is where across any blockchain or any distributed ledger is where it starts to become a little of a gray area. You know what I mean? Greg, can you hear me now, buddy?
I can, awesome, yes.
Oh,
Can
great,
verify, thank
awesome,
you.
cool. Yeah. So, like, a question I had, with it being essentially, because we agree that it's distributed ledger, but it's not a blockchain, right? A hash graph is not a blockchain, but because it's running distributed ledger tech and it's essentially proof of stake, right? That's where the gray area comes into the decentralization aspect of the trilemma, as far as like, well, proof of stake on a traditional blockchain is viewed widely as kind of pay to play. You pay enough to own enough validators, and then you earn fees off transactions, and it's kind of like the rich get richer kind of idea. On Hedera, what is the incentivization essentially model to keeping your node running, or is it an uptime type mentality? Is it number of transactions that are truthful? What is what's the incentivization to keep a node running on a hash graph?
Yeah, happy to take this one. I see Patches has his hand up. Just one thing I wanted to mention on the previous question or comment. Hashgraph or Hedera being based on the Hashgraph algorithm, being based on a DAG instead of blockchain, still achieves the same result of being able to process transactions, manage balances for accounts, run smart contracts. It's like, I mean, the only way I could say is, some vehicles, trains have, solid wheels and cars have rubber wheels, but they both, achieve transportation. So if the wheels are the blockchain and DAG equivalent, at the end of the day, it's what the technology serves, which is identical regardless of the underlying building blocks. and I've forgotten your question now. Sorry.
Oh, yeah, you're giving it. No, I agree 100% with what you said. Yeah, it's essentially at the end of the day, it's all distributed ledger tech.
Yeah,
It's
that's
just
it. Yeah.
different flavors of ice cream. But what's the
Operating
incentivization?
nodes.
Yeah.
Yeah.
Uh, yeah.
So because Hashgraph runs, or the consensus is somewhat different, and maybe we can go into that later on, than other networks. The nodes are essentially compensated for participating in consensus. So the butter, if you want, for transaction fees is being spread across all of the nodes that are participating in the network, as opposed to being given to those validators that reach the holy grail of being block producers and able to collect transaction fees. So the incentive for operating a node is being as available as possible in order to ensure that participation in consensus is as consistent as possible, and that earns the highest fees. But all things being equal, every node owns more or less the same returns.
Oh, that's so. Does it? Does the node, I guess, structure as more nodes become into the ecosystem, right? Like if community nodes start getting spun up, things like that. Do the existing nodes, does their essentially, I'll say fee, right? But their cut or whatever. Does it then ultimately going to go down, or will they get rewarded for having a longer amount of uptime?
No, the fee payments to the nodes would end up being reduced the more nodes there are on the network. Because the same transaction fee is divided by more nodes than if there were fewer.
Right on. Also, I think we may have lost TMC Patches. Do you guys see him on stage? Not getting rugged here, or
He's back. He's back. Patches, I know you had your hand up, man. Please take it away.
Man, Twitter is just killing it today.
wait, hold on.
It
Wait,
is,
you
yeah.
guys can see Patches on the. Is he on the speaker panel right now? Is he talking?
He is. No, he's on the
Oh,
panel, yeah.
all right. He just requested on my side. All right, he's now on my side at least. Let me know, Patches. Please
Can
say
you hear
something.
me
Let me know.
now?
All right, I can hear you now.
Jeezy, I opened up Twitter and it was a blank screen for like 2 minutes. This is just a bad day for Twitter. Um, I wanted to comment when Greg was talking. He did a great job on what benefits are brought on when you have Hashgraph. I just want to touch on the user experience. So when we're looking for adoption and someone is used to a mobile experience where load times take 3 seconds, when you have a network that has the ability to come to finality in 3 to 5 seconds, it's highly important for that user experience so that they don't need to know the underlying architecture or the technology. They're just using a mobile app, and that mobile app is using some technology under it, but their experience is good, fast, quick, and secure. And that's, I think, the benefits that Hashgraph lends to blockchain protocols is that they can work together where you can have a user experience layer like a Hashgraph or using the Hashgraph consensus service or their consensus service to log really quick, needed information while also interacting with your mother chain or your Ethereum or Bitcoin. So I wanted to touch a little bit on that. It's the user experience that can really help get adoption for the entire ecosystem. That's really exciting about that consensus mechanism.
So are there still is it still like wallet to wallet essentially transactions that are happening on the hash graph? And that being the case, I mean, is it still like SHA-256? Are there other benefits to having, a wallet in that ecosystem from a user standpoint as, to just spinning up now, I know that today we saw Coinbase launch their smart wallet, multi-chain, blah, 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 pass keys instead of seed phrases, all that stuff. Right, which I think ultimately will aid in adoption. I don't think it's going to be like the holy grail of mass adoption, but I think it'll help. Are there any benefits really to operating in that ecosystem on Hedera with the way that the user wallets are designed?
Yeah, so the security is ED25519. So I think it's theoretically quantum resistant. And there's multiple different wallets, like Karate Combat is built on Hedera. up-only gaming is built on Hedera. We just saw that at Consensus, amazing fights. The CEO of the biggest wallet on Hedera, Hashpack, fought in the karate battle. So if you saw Mei Chan, she won her fight. She actually is a trained amateur kickboxer and then got to fight in karate. But there's a lot of actual use cases that a lot of people know about but don't know it's built on Hedera, which is sort of the point, where you can have that fast interaction and that secure interaction that is crypto native in a user experience that just onboards the masses. And again, I'd point it at karate for that. And then a lot of the transactions that actually happen on the network are using the Hedera consensus service. So that's actually logging about up to a kilobyte of metadata using the consensus of the governing council of all the consensus nodes to come to a nanosecond timestamp of that metadata in a linear fashion. So really boiled down, it's like a sequencer as a service. You get a sequence number, you put data, you get consensus. And so Hedera lends its consensus for that. And our biggest use case, as Greg pointed out, is Atma that tracks supply chain data all over the globe. And so if you bought a organic salmon at a farmer's market, you can see it came from this distribution center that actually came from this farm, and that's all on chain. And I apologize, I do have a meeting 2 minutes ago, so I'm gonna have to pop off. And I'm sorry that Twitter rugged me so hard, but I appreciate you guys giving us the time, and I know Greg and Hedera can take it away from here.
All good. It was great to have you, Patches. Really appreciate it. Greg, I saw
Thank
you
you,
unmute your
Patches.
mic. Go ahead.
I know, I was just unmuting in preparation for the next intervention.
Gotcha. He's ready. Question about a little bit here as far as decentralization I wanted to dive into. So you guys have a leaderless architecture, which some people that raises big alarms. Some people are super hyped to hear about that. But one thing there is that it potentially helps prevent central points of failure within the network on Hedera. So we'd love for you to open that up a little bit and how that leaderless architecture helps in preventing that.
Yeah, sure thing. Great question. So like I said earlier, with the majority of traditional blockchains or distributed ledgers, as we like to call them now, there's an election that takes place. Clearly, this doesn't happen on proof of work, but a sort of an epoch is defined at the network level, and for the duration of that epoch, the list of block producers to come is predetermined and known to the general public. It's known to the network. I can query a network and ask, who's the current block producer, who's next, and so on and so forth. It's often posted on websites as well, so it's available for all to see. And in many respects, if we imagine somebody wanted to DDoS the network and prevent block production, they know they have an easy target, right? It's painted there on the website or in the network. I can determine who is currently in charge of producing blocks, and I can direct my attack at that block producer, preventing him or her or it from producing blocks, and therefore rendering the blockchain in question pretty much useless. I've not had to spend any cryptocurrency. I've not had to acquire stake. I'm not running a node. I'm not participating in a network. I'm just using traditional DDoS technology to attack a node at a time. And I know who's next. So I can already prepare my next attack, and I can just, pepper pot all the different nodes one after the other. And we haven't seen it yet. And I suspect we won't see it for a while because the intrinsic value of the current networks is not high enough for a state actor or a very wealthy individual to want to do this. But as we get into more important use cases where finance is, or these networks become critical to the operation of a country or world finances, then those questions become far more relevant in terms of attack surfaces. So this is the old world, and this is how it is in most networks. With Hashgraph, because of the gossip about gossip that I mentioned earlier, when I send my transaction to the network, I send it directly to a node of my choice. My transaction doesn't go into a mempool. It doesn't sit there for a period of time until a validator decides to pick my transaction up and put it into a block. It's immediately processed or sent by the node that I sent my transaction to for consensus. And all of this happens in parallel. So every single node on the network is continuously receiving transactions from end users, and forwarding those transactions to the network through gossip about gossip for virtual voting and inclusion in consensus. So what that means is to stop consensus on the network, you would have to to stop transactions flowing into the network, you would have to attack every single node. And that would be the equivalent of doing a DDoS attack on a single validator. And then secondly, in order to prevent the network from reaching consensus, you would have to attack at least a third of the nodes and render them unable to process transactions rather than just receive them. So this is why we believe a leaderless architecture is far more resilient and has fewer points of failure, because in the context of decentralization, that leader node, that validator, or rather block producer, is in charge for a period of time of deciding what goes into a block, in which order it goes into a block, at what price points a transaction's included into the block. It's highly centralized at a very, very, very moment in time by that node in terms of decision making. A leaderless network has none of these drawbacks. It's impossible for a node to block my transaction. I can always send to another. And if I suspect that a node is inserting transactions before mine to sandwich it, I have a choice. I can send my transactions to another node. I can even send my same transaction to 5 different nodes and hedge my bets. Only one of them will reach consensus. The other ones will be rejected as duplicates. But that essentially means that anyone trying to sandwich my transaction will be spending that little bit more time doing so, which will mean that their transactions will not reach consensus before mine.
Yeah, Brad, I see your hand. Over to you.
Yeah, I mean that all tracks. That all makes sense. I had a question about essentially independent node operators, right? Because I think like some of the node operators that exist currently on Hedera are more so like enterprise type environments. Yeah, like for an independent, like if I wanted to spin up, a node, are we talking as far as I guess voting power, right? Is it based on total number of nodes that are pooled? Is there going to be like a pool of maybe community nodes, a bunch of like just average devs here and there all over the world that want to participate? Pooling nodes together, and then realistically, how long does it take? Like, do I have to download the entire history of the hash graph up to that point, like you would have to download state on, a traditional block Bitcoin, we'll say. If you spin up a Bitcoin node, it takes several hours to sync. What's that look like on Hedera?
Right. So I guess the first, in full transparency, and anyone researching into Hedera will soon find out. So there's no state secret here. Operating your own node on the Hedera network is currently not possible. It is permissioned but public. So node operation is subject to council member approval or council approval. And we can talk about the governing council in a minute. But essentially, the 30-something nodes that exist on the network, 35 I think today, are operated by the governing council, and no other node operator is currently allowed on the network. We're working on what we call community nodes, which will remain permissioned, and this will open up node operation to a broader set of operators, again at the council's discretion. And eventually we will go fully anonymous, permissionless, like every other network. And it's a journey. And again, I can explain the whys and wherefores. But essentially, to your very specific question, the consensus nodes on the Hedera network only retain state and approximately 3 minutes of transaction history. So state is what? It's my account balance, is smart contracts and the data inside of smart contracts. It's topics, native tokens. These are tokens without smart contracts on the network. It's everything you need to know about in order to answer, does Greg have so many USDC, for example? That's the only thing you need to sync when you start your node. So, we're at close to 50 billion transactions or beyond 50 billion transactions on a network. Those are stored on what we call mirror nodes, which are a network of read-only nodes that collect all the transactions from the network and persist them into a queryable format. They don't participate in consensus. So syncing up a node, even though we've processed over 50 billion transactions, does not require you to download all 50 billion. But if you wanted the entire transaction history as a mirror node, you would have to, download 50 billion transactions, which is several terabytes of data. Yeah.
Could community members essentially run a mirror node, since it's a read only, and it sounds like all you would need is storage space, right?
The source code is the code is open source in the Hashgraph GitHub repository. Anyone can run a mirror node, and again, there's this notion of needing the entire history of transactions, and in many respects, you need that history on blockchain because of the finality we talked about earlier. You can't prove that my transaction today or my transaction yesterday was valid unless it's inside a block that is still, valid within the blockchain. So for a transaction to be, known to be valid, it has to exist within the blockchain. And often we have this notion that we need a complete history in order to prove anything. Because Hashgraph reaches consensus 100% with 100% finality, you could start running a mirror node today and not worry about the entire history if your use case only cares about one particular or a range of accounts or a range of tokens or a particular smart contract or two. You can even filter what you persist in your mirror node. So we're kind of changing. There's this kind of mental shift, if you want, in how you can operate a mirror node, and storing the world's data as far as Hashgraph or Hedera is concerned in your mirror node is not always necessary. It's often a waste of time and effort. There are mirror nodes that will persist everything, but in many cases, we see people spinning up mirror nodes just for their own purpose with just their own history of transactions and state, because frankly, they don't care about my balance or my transactions. They only care about theirs.
That's really cool. Is there or could you possibly hint to maybe, would there be any incentive down the road as the network does scale and become more and more, I guess, gets closer and closer to that full decentralization model? Is there any incentive to run a mirror node, or could there be an incentive, do you think?
Yeah,
In your own opinion, realistically.
if you think of Etherscan for Ethereum, we call them indexes. We call them mirror nodes, or rather, the industry calls them indexes. We call them mirror nodes. Etherscan is making money on selling access to queries, access to data. One of our partners, Validation Cloud, is running a mirror node at enterprise scale with enterprise-grade infrastructure, and you can query them for free. But if you want high throughput queries, or rather, you want to make a large number of queries per day, they'll have subscription plans. So there are ways in which you can monetize the data. And one of the reasons that we've made the code open source is we really would like the community to come up with ways of making this possible for themselves. It's possible. If